Good day. We are group number 1 from 3EC and we will be discussing our design on process control block diagram. And our topic is about fruit packaging. My name is Zildjan Dayao and here are my group mates.
So when did food packaging widely used? During the Industrial Revolution, food packaging manufacture became a trend where the packages were made of glass, paper, and metal. The world population posed a threat in food distribution since the 1900s. During the war and economic failure, the world suffered great complications in supplies, which includes food distribution. As time progressed, food production, storage, and distribution became a wide-scale demand in the market. Due to the rising population, famine, and insufficient supply, food distribution wrapped in packaging has been a trend in recent years until today. In the 21st century, unprocessed food such as fruits are harder to distribute due to its composition. Fruits are natural consumables that are harvested from different types of plants, which is why microorganisms such as bacteria and molds invade the fruit as a natural process of microbiology. Microorganisms release their own enzymes as they grow, speeding up the spoiling process, which is why different types of fruit packaging processes were developed, from regular fruit packaging to intelligent packaging systems. Using intelligent packaging systems, sensors and nanosensors are utilized to monitor food quality and safety. Freshness sensors or indicators can sense and inform about the quality of fruits in terms of their freshness level, ripeness, or firmness. Therefore, fruit freshness sensors are on-package indicators that monitor the environment inside or outside the package and allow the consumers to make informed decisions about the quality of the fruits. Smart packaging and/or sensors refer to an embedded system, which is a combination of electronics and electrochemical, electro-optical sensors that are near packaged fruits, allowing continuous monitoring of the quality of packaged fruits once the package leaves the plant until it reaches to the consumers. The use of freshness sensors in fruits packaging vastly depends on the type of fruits and the fruit's physiology. Smart packaging solutions utilize a variety of sensor technologies to recognize and resolve problems in fruit packaging. There are two types of freshness sensors, namely direct and indirect sensors. Direct sensor detects a particular analyte directly from the fruit as an indicator for food freshness. On the other hand, an indirect sensor is based on reaction-based detection of fruit's degradation due to certain freshness parameters such as temperature and/or time. The sensor or indicators are integrated into the food package as a visible indicator, label, or tag that undergoes color changes according to changes in the freshness markers and/or analytes. So, how do sensors determine the freshness of fruits? First is by spoilage. The spoilage of fruits is caused by the deterioration of their quality when they are no longer edible. Detection of spoilage can be done using chemical sensors, including a pH sensor that perform real-time monitoring of the fruit's freshness. pH indicator dyes are used that undergo color change when put into an acid or base. When a fruit spoils, it releases different types of volatile organic compounds, which can be detected with pH sensors. For ripeness, the sensor becomes red, indicating crisp at the beginning, and changes to orange or firm, and then finally to yellow or juicy with increasing ripeness. The use of this sensor can also reduce fruit damage and shrinkage, which may be caused by the handling and inspection of fruits by the consumers. Next is leak. The freshness of packaged fruits can be compromised by the package integrity. Hence, leaks can pose a significant challenge in maintaining the freshness of packaged food. Therefore, leak sensor or indicator can be used to monitor the integrity of packaged fruits that are directly related to fruit freshness. The leak indicators are typically gas indicators that can indicate whether there are any toxic composition of gases produced from the decomposition of packaged fruits, endangering consumer health and safety. Last is microbial pathogens. The easiest way to detect microbial contamination is by measuring changes in gas composition inside the package caused by microbial growth. Detection of microbial spoilage due to CO2 is difficult in a fruit package that already has a high concentration of CO2. Therefore, gas detection-based microbial pathogen sensor may only work in packages that do not contain any CO2 gas. These sensors are based on changes of color, which motivated the widely developed optical-based biosensor, together with acoustic transduction systems. Indirect detection freshness relies on markers including temperature and storage time. The rate of the change of sensors should be correlated with the deterioration rate of the packaged food over time during transportation, distribution, and storage. The indirect sensor should indicate the results in terms of change of color and electric signal output when exposed to abnormal storage temperatures and/or humidity. Temperature and humidity inside the fruit package is an important factor to monitor freshness. The freshness of fruit products may rapidly change due to improper temperature and relative humidity conditions throughout the transportation and storage. Last is time temperature. The chemical and physical mechanisms are based on chemical reaction or physical change respectively due to the changes in time and temperature.
I am David Gabriel Aquino and I'm going to discuss the materials used. Number 1. RFID-based sensor system. Most of the previous sensing systems discussed focus on the quality of the fruits or fruit products, but there's still significant data that can be collected from the fruit container itself. Intelligent packaging can also make use of radio frequency identification device or RFID technology to track and identify the product quality during storage and transport in containers. RFID tags are electronic barcodes used to identify individually packaged units whose data can be stored on a network and accessed later as needed. These systems require an RFID tag with an antenna, an RFID scanner, and utilize radio waves to communicate data to a network. The tag itself is an IC with an antenna held together with a protective covering. Next is carbon dioxide non-dispersive infrared or NDIR sensor. A NDIR sensor uses infrared light absorption to determine the concentration of specific gases. The consumer packaging with modified atmospheric environment helps to ensure higher levels of carbon dioxide and low levels of oxygen within the package. A low oxygen atmosphere slows down respiration and prevents the early ripening or fruit death. However, too low levels of oxygen can cause cell death, leading to a premature decay. Thus, the monitoring of atmospheric gases with the techniques such as non-dispersive infrared sensors can help ensure proper packaging conditions. Lastly, wireless sensor network. It is defined as a self-configured and infrastructure-less wireless networks to monitor physical or environmental conditions such as temperature, sound, vibration, pressure, motion, or pollutants, and to cooperatively pass their data through the network to a main location or sink where the data can be observed and analyzed. A wireless sensor node is equipped with sensing computing devices, radio transceivers, and power components.
My name is Zildjan Dayao, and I will be discussing our control process block diagram. Let us proceed to the next slide. Let us start off by understanding the design flow before implementing the block diagram. So in here, the general process of our design is listed. At the first part, the fruits of choice will be loaded on the system on way to the conveyor, which will be passed on to the disinfection box wherein the fruits would be cleaned with water for provided safety to the consumers. Then the most important part of our design, the inspection, for identifying the quality of fruits using sensors. In here, we determine if the fruit is safe or will bring satisfaction to the consumers in terms of its freshness or quality. This section utilizes the group's knowledge regarding effective usage of sensors. As the process goes on, the selected good quality fruits will be on face to the packaging section and be ready for distribution to the public. It is important to have a concrete flow diagram in order to guide the actual block diagram and meet the requirements or standards that the group has set for this design project. Here, we have the block diagram on how the project will work. It starts with fruit and it is handed onto the sensor plate. It allows the user to input desired parameters, the ripeness level detection or the temperature, and the microcontroller then performs automation to which, after doing its first cycle, will then light up the LED light to determine the status of the fruit and will also show a monitor to determine its freshness state display. In relation to the actual block diagram, the process for our design involves two variables to be controlled or measured, which is the freshness or ripeness and temperature of the fruit. Temperature can be controlled to achieve customer satisfaction, while ripeness is an independent variable because it is what it is. Our design will also be implementing the basic structure of the measurement process. Moving on, let us discuss our created measurement process for our project. It is almost the same with the original, but we modified the sensor to be NDIR, and instead of ADC, we will be using LED lights to trigger the fruit status actuation. To condition error signals, we selected the filtering technique in order to avoid mistakes that may label overripe fruits as good quality. Therefore, the customers will receive the best quality fruits. The process control technique that we chose is the composite control, proportional, integral, and derivative method, because it is responsive and still eliminates offsets, which increases our design's efficiency. For the control elements, we will be using transducers to convert signals to the LED light, an actuator to respond to the transducer and allow the good quality fruit to the packaging section, wherein the final control element, the RFID system, will be stamped on the packaged fruit.
I am David Gabriel Aquino, and I'm going to discuss the demonstration of the different parts of the process diagram. For the sensors, first is the RFID. In supply chain management, RFID tags are used to track food products during distribution and storage. RFID technology serves as a replacement for barcode scanners for this particular application. An example of an RFID is fresh time semi-active RFID tags. These monitor the shelf life of the foods to which they are attached. The tag senses temperature and integrates it over time to determine the shelf life of a product, which can be communicated to a reader. RFID systems can be used to ensure that food products such as meat, fruit, and dairy products remain within the safe temperature range during transportation and storage. Next is for NDIR. NDIR uses ethylene, which is a plant hormone that plays an important role to the ripening process of various fruit, such as apples, bananas, and tomatoes. During the storage, the metabolic process of fruit and vegetable continue. As a result, quality and the degree of ripeness change during this time. Correct storage under the relevant ambient conditions can delay these phenomena. Lastly, wireless networks. The use of wireless networks in refrigerated vehicles was proposed by King Shan in 2004, and the vehicle can host variety of sensors to detect, identify, log, and communicate what happens during the journey and monitor the status of perishable products during the transport process. Wireless network uses QR codes to show the user all about the information of the fruit, like its transportation date.
Good day, I'm Jiever Cañal, and I will be discussing the advantages and disadvantages. Firstly, I will discuss the advantages and disadvantages regarding the fruit packaging sensors. For the advantages, it is easy to use when it comes to sensors to detect spoilages, namely the pH chemical sensors that have pH indicator dyes. It is also highly effective when it comes to sensors that detect spoilages because it has high sensitivity and can easily detect changes. Sensors regarding the detection of ripeness can be used in bulk packaging. Also, sensors that involve spoilage, ripeness, ethylene detection provide accurate outputs and can really be highly reliable. Lastly, spoilage detection sensors are named to be cost-effective. Moving forward for its disadvantages, limited quantitative data is observed on sensors involving spoilage detection, for it is mainly based on pH levels. Sensors which have chemicals used for their detection provides migration of chemicals to food. Even though some sensors are cost-effective, there are sensors that are also costly when it comes to ripeness sensors. And lastly, interferences and sensitivity cannot be disregarded because of natural phenomenon like temperature and humidity. It is obvious that reactions may occur and inaccurate data can be provided by the sensors. Moving forward for the advantages and disadvantages of the materials or equipment used in the system, firstly, the RFID sensor or radio frequency identification sensor. For its advantages, it provides greater data storage because RFID tags can store more data such as tracking the origin of a product, its location, and its journey through the supply chain. Plus, that data can be read even in remote locations. It is also known for more flexible scanning. RFID does not require line of sight for scanning, meaning the tag can be read from any orientation. Also, RFID scanners can read multiple tags at the same time. Next, it also has an increased tracking accuracy. With RFID readers placed at each portal or doorway, you know exactly when inventory enters or leaves a location. It also has improved traceability data. It is known that RFID technology can be used to track a product during production. It allows you to immediately locate a product on the production line and track its status, which can be used to optimize your production process. And lastly, it is highly reusable because they are protected by a plastic cover. Going to its disadvantages, given its complexity and added features, RFID sensors are costly. There are followed conditions when it comes to RFID sensors. Since RFIDs provide a lot of more information, a system will need to be designed to accommodate all this data, so a larger infrastructure may be required. Next is that it has some security risks. Some RFID readers are portable, and the range of some tags are so great that almost anyone could gather information they would not otherwise be able to access. Since RFIDs are sensors that operate on radio frequency, it will also face certain interference problems. And lastly, is its setup time. Since configuring an RFID system can be labor-intensive and time-consuming for its complexity. Next material is the NDIR sensor or the non-dispersive infrared sensor. For its advantages, this sensor is capable of not being easily destroyed, for it is not susceptible to poisoning. It also does not burn out when exposed to high concentration of gases and rarely require calibration. It is known that the sensors that have a long lifespan and can even detect gases in low oxygen environments. It also has a fail-safe system so that inoperable sensors can be easily detected. As compared with other sensors like catalytic bead sensors, it is much cheaper. Since NDIR sensors is one of the newly produced sensors, it can be a huge leap in gas detection technology. The disadvantages of the sensor is that, firstly, it is limited in gas detection due to certain conditions like its failure of hydrogen detection. NDIR sensors cannot detect hydrogen because this gas does not absorb infrared light. Since hydrogen is one of the most dangerous gas because it is flammable and combustible gas, it can also lead to potential risks and danger. Next, it is highly susceptible in the environment's temperature and humidity. It makes the output during temperature transitions to freeze. The function poorly in extreme environments or where there is a rapid change in conditions. The design of NDIR sensors also allows humidity, fog, and ambient infrared light into the open chamber, all of which can cause interference. This interference can impact their reliability, providing another opportunity for these sensors to fail and potentially expose workers to risk. It also has limitation due to sensors design because it requires a great amount of power to function and frequent calibration, which contributes to higher total cost of ownership. And lastly, when not compared to other sensors that have similar functions, it is still costly when purchased individually. For the last material used, it is the wireless sensor network, and just like the other apparatus, it has its own advantages and disadvantages. For its advantages, it is effective in harsh environments. wireless sensor networks were first developed for battlefield surveillance in military engagements. Situations where building a wired network of sensor devices would essentially be impossible. These difficult conditions created a need for a wireless sensor network that could be deployed with minimal risk and used to monitor environmental conditions in the battlefield. It also offered an easily scaled solution. The typical network architecture of WSNs make them an easily scaled solution for conducting environmental surveillance. Long-distance data collection and transmission is also an advantage for this sensor. Each sensor node in the WSN acts as a relay station between other sensor nodes in the network and the main location where the data must ultimately be transmitted. Lastly, it can serve as a protection of hardware and data assets. Wireless sensor nodes make it easier for corporations to realize the benefits of real-time temperature sensing in their data centers, without adding a lot of extra cabling into the environment. And its disadvantages are the following. It has vulnerability to malicious security attacks, as these sensors often lack any robust security systems. WSNs may be large and span a wide area, meaning that there are many sensor nodes that could serve as an access point to the network for a malicious attacker. And lastly, the network is composed of low-energy and short-range devices. They need to be inexpensive because there are frequently so many of them deployed in the same network. Some engineers have discovered that periodically toggling the power on the sensor node can extend their operational lifetime, but this practice can lead to network latency and routing overhead. Therefore, such problems needs to use sensor nodes that have ample battery life and transmitting capabilities, and use sensor nodes that are inexpensive to purchase and operate. I am Jiever Cañal, and I will discuss the summary. Given all the data and the information gained in this report, its conclusions are as follows. Firstly, smart packaging of fresh produce is an emerging technology toward reduction of waste and preservation of consumer health and safety. Smart packaging systems also help to prolong the shelf life of perishable foods during transport and mass storage, which are difficult to regulate otherwise. The use of these ever-progressing technologies in the packaging of fruits has the potential to result in many positive consequences. Next is that the simple application of such devices in fruits can further enhance and use for other purposes, meaning it cannot be enclosed to fruit packaging only. Also, the process includes a straightforward objective and simple steps to get the job done. And lastly, these sensors hold its own advantages, but still hold some disadvantages when it comes to the usage of different components that are included in the system, as discussed.